Hello viewers, in today's class we are going to discuss five very important problems from logarithmic differentiation, right? So in this lecture we are going to find out the derivative of these five functions where we have to use the concept of logarithms, right? So here we'll see how we can utilize the concept of logarithms and the properties of logarithms to find out the derivative of these functions easily, right? So let us find out dy over dx, that is the first derivative for these functions, one by one. So let us first take this problem, that is y is equal to x raised to 2x, right? So whenever we come across with the functions where we have functions of this form, that is fx raised to some function of x, right? So here we can take fx as x and g of x as 2x, right? So whenever we have functions of this kind, what we usually do, we take the logarithms of both sides, right? So let us take the logarithm of both sides. So we have log of y, and here we have log of x raised to 2x, right? So here we can use the notation ln for log, right? So here it is understood that the base of logarithm is exponential number e, right? So here I will prefer this notation, a log of e, or simply log for ln, right? So after taking the log of both sides, now see here we have log x raised to 2x, right? So we know an important property of log, that is the power rule. If we have log of m raised to n, then this n, it comes in front of log. So we have n log m, right? So we'll make use of this property. So here we have log of y, and here we have this 2x. So this 2x can be taken in front of log. So we have 2x log x, right? So now we have this function, right? Now we can differentiate both sides with respect to x, right? So what we'll have, we have d by dx of log of y, and here we have 2 as the constant, so we can take it outside. So we have d by dx of x log x, right? So now see, here we have the derivative of log y with respect to x, right? So we know that the derivative of a log of y, when y is a function of x, x itself, then the derivative of log y with respect to x is 1 over y. That is, first we'll differentiate log y with respect to y, right? So we have 1 over y, and then we have dy over dx, right? So the derivative of log y with respect to x is 1 over y dy over dx. So here we can write 1 over y dy over dx, and here we have 2 and the derivative of product of these two functions, right? And we know the product rule, that is, if we have two functions of x, u and v, then the derivative of the product uv is u, then derivative of v, and then v and derivative of u, right? So here we can take u as x and v as log x. So we have x, then we have derivative of log x, and then we have log x and derivative of x, right? So now we have dy over dx. We can take this y to the right hand side. So here we have 2y, and here we have x times derivative of log x is 1 over x, and log x times the derivative of x with respect to x is simply 1, right? So here we have used this result, that is x raised to n. The derivative of x raised to n is nx n minus 1, right? So we have dy over dx, and this is 2y, and here x and x get cancelled. So we are left with 1 plus log x, right? And now we can replace this y by x raised to 2x. So here we have x raised to 2x, and here we have 1 plus log of x, right? So the derivative of x raised to 2x is given by 2 times x raised to 2x times 1 plus log x, right? Now let us take this second problem. So here we have y is equal to x raised to uh, ln x, which is log of x, right? So now we can take a log of both sides. So we have log y, and here we have log of x raised to log of x, right? So we can now write log of y, and again by this rule we have log x in front of this log. So we have log x, this log x, and then we have simply log of x, right? Okay, so now see, we have now log y is equal to log of x square, right? Because here the exponent is 1, here also the exponent is 1. So we have log of x square, right? Now we can differentiate both sides with respect to x. So we have d by dx of log of y, and here we have d by dx of log of x square, right? Now again, the derivative of log of y with respect to x is 1 over y dy over dx, and c, here we have the derivative of log of x square with respect to x, right? So here I will make use of the chain rule, right? So first what we will do, will take help of this result, that is the derivative of x raised to n is nx n minus 1. So first we'll take log x as x, and we'll apply this rule. So n is 2, so we have 2 times x raised to n minus 1. So x is log of x, and here we have 2 minus 1, and then by chain rule we have to differentiate log of x with respect to x, right? So now taking this y to this side, we have dy over dx is equal to 2y, and here we have log x raised to 2 minus 1 is 1, and the derivative of log x with respect to x is 1 over x, right? Because we know that the derivative of log x with respect to x is 1 over x, right? So now replacing y by x raised to log x. So we have 2 x raised to log x, and here we have log x, and this is 1 over x, right? Now see, here we have the power x raised to 1. So we can take x raised to 1 to the numerator. So we have 2 times x raised to log x minus 1, right? So power gets here we can use the rule from exponents, that is a raised to m divided by a raised to n is a raised to m minus n, right? So we have x raised to log x, here we have x raised to 1. So taking x raised to 1 to the numerator, we have log of x minus 1, and then here we have log of x, right? So the derivative of x raised to log x is given by this expression, right? Now let us take the third problem, right? So here we have y is equal to 10 raised to 3x, right? Again, what we will do, we'll take the logarithm of both sides. So here we have log of y, then here we have log of 10 raised to 3x, right? So using this property, log of m raised to n, here n is 3x, m is 10. So we have 3x in front of log, and here we have log of 10, right? And remember here the base is e, right? Now differentiating both sides with respect to x, we have d by dx of log y, and here 3 being a constant, we have this log of 10 is also a constant, and we have d by dx of x, right? Because 3x log of 10. So 3 log 10 is a constant, so we can take it outside, and we can simply write the derivative of x with respect to x, right? So the derivative of log y is 1 over y dy over dx, and here we have 3 log 10, and the derivative of x with respect to x is simply 1. So this is 3 log 10, right? Now taking this y to this side, we have dy over dx, that is 3y log of 10, right? And replacing y by 10 raised to 3x, we have 3 times 10 raised to 3x, and here we have a log of 10, and obviously the base is e, right? So the derivative of y is equal to 10 raised to 3x is given by this expression. Now let us consider the fourth problem. So here we have y is equal to x raised to tan inverse x, right? And again, what we will do, we'll take the log of both sides. So we have log of y, here we have log of x raised to tan inverse x, right? So we can now write log y, and applying this result, we have here tan inverse x in front of this log, so we have log of x, right? Now differentiating both sides with respect to x, we have d by dx of log y, here we have d by dx of tan inverse x, and log of x, right? And now the derivative of log y with respect to x is given by this expression. So we have 1 over y dy over dx, and c, here we have the product of two functions. So we'll again resort to this rule, that is, this is u, this is v, right? So we have tan inverse of x, the first function, derivative of second function, then we have log of x, and then the derivative of tan inverse x, right? So we have 1 over y dy over dx tan inverse x, and c, the derivative of log x is 1 over x, so here we have 1 over x and log x, and we know that the derivative of tan inverse x is given by 1 over 1 plus x square, right? So here we have 1 over 1 plus x square, right? Now taking this y to this side, that is multiplying this whole quantity by y, so we have dy over dx is equal to y, and we have tan inverse x divided by x plus log x divided by 1 plus x square. And now replacing this y by x raised to tan inverse x, we have x raised to tan inverse x, then we have tan inverse x over x plus log x divided by 1 plus x square, right? So the derivative of this function is given by this expression, right? Now let us take this problem, that is the last problem. Here we have y is equal to x raised to e raised to x, right? So again, what we will do, we'll make use of the property of logarithms. So taking log of both sides, so here we have log of y, and here we have log of x raised to e raised to x, right? Now see, here we have n as e raised to x and m is x. So what we will get, log y, and we'll take e raised to x in front of this log, right? So we have log of x, right? Okay, so now differentiating both sides with respect to x. So what we will get, d by dx of log of y, and here d by dx of e raised to x, and here we have log of x, right? So the derivative of log y is 1 over y due to this result, and here again we have the product of two functions, right? So we can take this as u, this as v. So applying this product rule for differentiation, we have here e raised to x, then derivative of log x, and then log x and derivative of e raised to x, right? Okay, so now we have 1 over y dy over dx, and here we have e raised to x. The derivative of log x is simply 1 over x, and here we have log of x, and we know that the derivative of the exponential function is the function itself, right? So the derivative of e raised to x is simply e raised to x. So here we have e raised to x, right? Now taking this y to this side, so we have dy over dx. So this is y times e raised to x over x plus e raised to x and log x, right? So now replacing y by x raised to e raised to x, so we have x e raised to x, and taking e raised to x common from these two terms. So here we have e raised to x, and now we have 1 over x plus log of x, right? So viewers, this is the derivative of this function with respect to x, right? So viewers, in this lecture we have seen that how we can find out the derivative of functions utilizing the properties of logarithms, right?